In this video, we will review the process of rectification. In a previous video, we reviewed the components of the X-ray circuit and gave an overview of how electricity travels across two circuits, the main circuit and the filament circuit. The rectification system is located in the main circuit, where it converts alternating current to direct current. This graph diagrams alternating current, or AC, which travels in both directions. The current flowing in the positive direction is represented by the sine wave above the line, while the negative current is shown below the line. This is important to understand. Alternating current travels in both directions, while direct current, or DC, only travels in one direction. Because of this, DC, or direct current, is often diagrammed as a straight line. However, when we are discussing rectification, we typically do not diagram DC as a straight line, as you will see. Next, let's look at why direct current is necessary in creating a radiographic image. We know that the electrons travel from the negative side of the X-ray tube to the positive side of the X-ray tube, or from the cathode to the anode. But if the current went in the opposite direction, from the positive side of the X-ray tube to the negative side of the tube, the current would be traveling from the anode to the cathode. Now the cathode is made of small filament wires that would not be able to handle that amount of force. As a result, the X-ray tube would be destroyed. It wouldn't necessarily blow up, but the filament wires would break, much like a light bulb filament when it burns out. So how can the current be prevented from traveling from the positive side of the tube to the negative side of the tube? This can be accomplished through a series of diodes that are added to the main circuit. Diodes are made from semiconductor crystals that only allow electrons to travel in one direction. This symbol shows the direction of the current, although it isn't quite intuitive because the current can only travel against the direction the arrow is pointing. The diode will not allow current in the opposite direction. Another video goes into more detail about how diodes work. For now, all we need to know is that a diode prevents any electrical current in the opposite direction. Here is a simplified rectification system. As you can see, the current is able to pass through the diode in one direction, and the electrical current continues across the X-ray tube from the cathode to the anode. When the current tries to head in the direction of the anode, the diode stops the current. If we graph this current, it would now look like this. Notice there is no current on the negative side of the diagram. This is half-wave rectification. Half of the wave is still there, and half of the wave was blocked by the diode. When the current flows from the other direction, again the diodes allow the current to travel to the cathode, but prevent the flow of electrons to the anode. Again, if we graph the current, it would look like this. No flow of electrons in the negative direction. This again is half-wave rectification. Now we need to understand that the flow of electrons is actually taking place at the approximate same time and looks somewhat like this. Again, this is a simplified drawing meant to help you understand the process of rectification. In reality, it is more complex. Because the positive flow of electrons is allowed to continue to the cathode, and the negative flow of electrons is rerouted by the diodes and manipulated to flow in a positive direction, when we put both together, we now have what is called full-wave rectification. Full-wave rectification is more efficient and allows for greater energy or voltage to be transmitted across the X-ray tube. Let's review what you need to know. Rectification is the process of converting alternating current to direct current in order to be safe to cross the X-ray tube. Rectification occurs after the step-up transformer in the main circuit because transformers can only function on alternating current. Diodes are semiconductors that only allow current to travel in one direction. You should be able to identify the symbol for a diode and know which direction the current is able to flow across it. Manipulation of the electrical current direction through a series of diodes allows for higher energy and efficiency of the voltage that crosses the X-ray tube. This is full-wave rectification. you should be able to distinguish between the diagrams of both half-wave and full-wave rectification. Direct current travels from the negative cathode to the positive anode. If the electrical current travels in the opposite direction, damage can occur to the filaments in the cathode.